David Smith here with yet one more flipped classroom math lesson. 3 tips before we start. First, you can adjust the playback speed faster or slower to suit your desire. Second, you can pause the video at any point to jot down questions or catch up with your notes. Third, you can turn on the captions so you can read my words on the screen. Today, we're going to do a review of everything we did in Chapter 4, which is rational functions. Now, before we get started, remember the basic definition of a rational function is a function that has variables in the denominator on the bottom of the fraction. So in this chapter, we discussed 3 different forms, and so we're going to go over those real quick right here. We have f of x equals k over x. This is the most simple version of a rational function. It could be 4 over x or minus 2 over x, number of things like that. And it's also very simple because our vertical and our horizontal asymptotes are just at x equals 0 and y equals 0. So that's what this stands for, vertical asymptote, horizontal asymptote. And then this, of course, stands for domain and range. And the thing to remember about rational functions is that the only limits to their domain and their range are at the asymptotes. Remember, the asymptote is a line which the function approaches but never gets to. So in this case, it's just x can't be 0, y can't be 0, and it's an element of real numbers. Now we have a couple more formal notations to specify domain and range, and you'll need to know how to do those. So then we get to our second function form, and it's a little bit more complicated. Now we have p over cx plus d. So again, we have a constant on top, but now we're adding a constant on the bottom, and we're multiplying our x by something on the bottom. So check this out. Now the vertical asymptote is x equals minus d over c. And the way we found this little equation is we set the bottom equal to 0 and solve for x. And indeed, that's where the asymptote is, because the bottom of this function can't be 0 because we'd have a divide by 0 problem there. And then, of course, the horizontal asymptote is just this q sitting out there. It's just the amount it goes up or down. So then again, you have your asymptotes, and then again, our domain is just limited again by the asymptotes. So you're going to see that when we do domain and range, we're just going to repeat the equations for the asymptotes. And in that case, x can't be this and y can't be that. So you see that there. Now finally, our most complex form was ax plus b over cx plus d. So now we've got a lot of things going on. We've got 2 different constants that can be added or subtracted, top and bottom. And then we have 2 different multipliers that can be multiplied by our x. And then finally, this form has a variable in the top and in the bottom. So it's probably the most complicated rational function you're going to see here. So again, our vertical asymptote is the same, minus d over c. But now our horizontal asymptote becomes a over c. And that's our horizontal. And then the domain and range work out the same. Let's do an IB type problem with a rational function. So here's the setup. We have our function, but we have variables in the spots where we normally would have our numbers. So this is the second form from the last board, and there's no c in front of the x, but that just means c is 1. So let's check this out. They're telling us that the vertical asymptote is the line x equals 4, and the y-intercept is 0, 7. So there's some additional information that we're going to need to use with this expression to find some things. Namely, we need to find m and n. So pause the video and see what you get for that. All right, so I've copied a little bit more information for you in case you were stuck and couldn't go forward. Here is our function form for this function. You can see, again, our c is 1 in this case. And then here are little equations that came off that last board. Vertical asymptote is minus d over c, and the horizontal asymptote is q. So I think you can find this one pretty easy. This one takes a little critical thinking step. So this one's a pretty much a super easy one. You can just do it by inspection. We know the vertical asymptote is x equals 4. So that just means m is going to be 4 for this equation. So I just wrote m is 4. Now this one's a little bit more tricky. Go ahead and find the value of n. And your first step is a plug-in step, and it's a little complicated. So the key in this involves noticing that if this is the intercept, then this ordered pair of points satisfies our function. And now that we know what m is, we can use that and this point to write this equation. So the y value, y, is going to be plugging 0 in for x, and then we've got our minus 4 from our asymptote. Our asymptote's at 4, so this minus 4, and we've got our 5 over there. So all I did is I just did a plug-in step with my 7 and my 0 into my equation with the 4 that we got for our m value. So now pause the video and solve that and find n. So doing my math, I end up with 7 plus 5/4, which is 33 over 4, so that's my n. And then of course, if prompted, I would need to write my full equation, which indeed would be that. Not a pretty equation, but perfectly valid. One last prompt with this equation. Here it is. Here's our new equation that we got by finding m and n. So now I'm going to ask you, go ahead and find the x-intercept. Now, I'll give you one quick hint, and then I want you to pause the video and do that. What's y when it crosses the x-axis? What's the y value? And that would be 0. So you plug in 0 for f of x for y and solve for x. So do that, see what you get. Let's see how you did. So here's my plug-in step with my 0 on the left side and my function just coming on down. So the first thing I did is I subtracted 33 over 4 from both sides. Then I cross-multiplied to simplify to get rid of the fractions. And that left me with this statement here, minus 33x plus 132 equals 20. I rearrange, move my 132 over here, and then finally divide through by negative 33, and I get 112 over 33 is my fraction, and so there is my coordinate point for my x-intercept. All right, we made lots of graphs of these, so let's do one. Here we go. The thing you want to realize about graphing is you need your asymptotes. That makes drawing the curve super easy, and then the x and y intercepts also help you do that to get your graph in the right place, so be sure you draw it correctly. So here's our function, 3x plus 8 over x minus 1. X is an element of real numbers, but not equal to 1 because we get divide by 0 on the bottom. So I want you to pause the video, use the techniques from that last board, find me the vertical asymptote, the horizontal asymptote, the x-intercept, and the y-intercept. Do that math and come back. All right, here are my vertical, my horizontal, my x-intercept, and my y-intercept. If you didn't get those numbers, try that again. I'm not showing you the steps. So if you need practice with those steps, I would say, again, pause the video, use the equation to find these important numbers. And then now I want you to pause the video and create the graph. And I'll give you a couple tips. Plot your asymptotes first, then mark your intercepts, then sketch your curves. All right, let's see how you did. Here's my vertical asymptote at x equals 1, a horizontal asymptote at y equals 3, and then I plotted my two intercepts, which told me where my curves lie. If you don't find intercepts, then you don't really know whether your curve is in quadrants 1 and 3 or whether it's more in quadrants 2 and 4. So you'll need to do that step. So there's my graph. One last example. Hypothetical shirt company makes t-shirts. They spend $500 on their shirt machine, and then each shirt costs $10 more for the fabric. This expression gives you the average cost per shirt as a function of the number of shirts made. And you can see where our numbers from above come into this function. And you can see it's a rational function because we have variables in the top and the bottom of the denominator. First prompt, sketch this graph. If you look at the function, you'll see that the vertical asymptote and the y-asymptotes are 0. They are the axes. So I quickly sketched my graph doing that. Okay, here's your first problem. Find and show on the graph the number of shirts required to make the average cost equal $35. So you want to do that. So think about that for a minute. You can do this algebraically. You can also do this graphically. You can do this all on your graphing calculator as well. All right, so I did my algebra. I just set my average cost at 35, worked my equation, and I solved for S. And I can show that on the graph. If they make 20 shirts, they're going to end up with an average cost per shirt of $35. Okay, your next one, same idea. Now find out how many shirts it takes to make the average cost per shirt $20. All right, I just did my math again. I set my average cost to 20 and solved, found the S, that's 50. Go ahead and plotted that, and there is my result. Boom! Now that you've watched the video, take a moment to jot down extra notes or jot down some questions for our next class. You can also re-watch portions of the video that you didn't get the first time. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.